Okay, this is going to be the third time I've recorded this because I had some issues trying to get my lens clean on my camera. Anyway, I bought a set of 8 of these Nilight off-road lights. These are, per the website description on Amazon, supposed to be 18 watt modules. This is an 8-pack here, so I'm going to test all 8 of these lights. And there you can see, yes, they're the Nilight brand here. Apparently back in the day, these emitters drew 14.5 watts, according to other reviewers. So I've seen some other reviews saying that they have tested these and they're not drawing near the amount of power that they're rated for, which, unless they had a hyper efficient LED emitter, which I'm going to tell you they do not, these are definitely compared to a 100 watt equivalent LED bulb, which is usually between 16 and 18 watts, somewhere in that range of actual power, that you would buy from like the Home Depot. Those are much brighter than these are, so I can tell you subjectively already that these are not putting out quite the amount of light that they claim they are. And they're definitely, well, we'll see. We'll see how much power they draw. And you could probably estimate 12 to 15% efficiency in best case scenario. LEDs have a range of around 10% to 20% efficiency. So it can vary with the emitter you get, but a 20% efficient emitter is much more expensive than a 10% efficient emitter. And then incandescents, of course, are down around 1.5–2%, I think, in terms of efficiency. So we're going to test all 8 of these, see how much power they draw. One guy said he tested it at 12.7 volts and didn't draw more than 7 watts, I think. And that's under half of what these are rated for. One thing you have to keep in mind is LEDs, for it to be a halfway decent light, needs to have some sort of active regulation. Especially for a 12-volt system with a lead-acid battery, because you're going to have a charging system on there. If it's not running, your battery could be down 11.5, 12 volts. And then if you have a charging system, it can be between 13.8 and 14.5 volts. So we're going to test a couple different voltages here. I think we'll probably start with 10, 11, and 14.5 and kind of see how the light behaves at those different voltages and see whether it really draws the amount of power that it's been rated for. So without further delay, I guess let's get into it. This is going to be module 1 that I'm starting with, and we are going to set this at 10 volts. And I've set it to 5 amps. It won't draw anywhere near that much, so that'll just let it do whatever it needs to bring it up to 10 volts. And I'm going to face this down so I'm not staring at it. And of course my wires aren't colored correctly. I just used scrap I had laying around, and these banana connectors were junk. Anyway, let's get into it. At 10 volts, it is drawing 5.7 watts. That is less than a third of the rated power. At 11 volts, that is 10.11 watts. That is just over half of rated power. Module 1 at 14.5 volts, 9.86 watts. You notice how the power went up between 10 and 11 volts. And actually, since this is the third time I'm recording this, I already knew it was going to happen. You see that the power usage went up significantly from 10 to 11 volts, but at the same time, some active voltage regulation kicked in here, and it's not allowing it to draw more power. And you can see that the current is lower than what it was on 11 volts. So if I bring this back down to 11 volts, you can see the current went from 0.6-ish to 0.91 amps. So there is some active regulation in here. That's a good thing. But at the same time, even at 14.5 volts, which that's the highest you would expect from a normal automotive charging system that would have 12 volt lead acid battery and be considered 12 volt, it's still not drawing the 18 watts that it's rated for. So I'm going to go ahead and say that these, well, we'll test all the other modules, okay? But I would probably say these are not actually running what they're rated for. So technically the website description is incorrect, and that's very unfortunate. I think everybody would like brighter lights. They would like these to be 18 watt modules. So honestly, I think the manufacturer should stop cheaping out and put better parts in them. But each of these, this whole set of 8 was $50, so each of these is about $6, somewhere in that range. One other thing to take note of, how I said 11 volts, right? It stopped drawing power. Now we'll drop it to 10.9. It's still 10 watts. 10.8, 10 watts. 10.7, 9.5 watts. So your voltage regulation on this one is fully kicked in around 10.8. It is regulating it to 10 watts. And who knows? It could actually be the regulator that's underpowering these. And Nilight did advertise their LEDs as not dimming over time, and maybe the way they did that is actually by reducing the power usage on these modules. It's hard to say without opening it up, but so far this is pretty disappointing. Module 2 at 14.5 volts, 10.29 watts. If I drop it, 11 volts is about 10.5 watts. That's module 2. This is module 3 at 14.5 volts, and we are seeing 9.86 watts. So again, this is just over half of the power these are actually rated for. Okay, so this is module 4 at 14.5 volts, and it is drawing 10.3 watts. This is module 5 at 14.5 volts, and it is drawing 9.86 watts. Alright, so module 6 here, 14.5 volts, 10.15 watts. Okay, this is module 7, 14.5 volts. We are drawing 10 watts. Alright, this is module 8, last but not least. We're going to start out at 14.5 volts. And once again, 10.15 watts. So every single one of these modules drew just over half of the rated power. And again, you know, they're not particularly bright. I'm hoping they'll still be good for my application, but the more I come down here and repeat this test, the more I doubt it. They're just really not very bright lights, and of course it looks like it is there, but look at how close I am to the thing. So this is not very impressive. Definitely, I would say they're misadvertised. I would say the lumens rating is excessive on these. Now, in order to actually test the lumens, because lumens is a measure of your total luminous flux, it's different than your luminous intensity, which is kind of like a point intensity, like how bright is your light here. Instead, it's not about the brightness at a given point, but it's the sum of the brightness over an area, right? For the total amount of light output. If you took the same amount of light and shrunk it to a smaller area, that particular small area would be brighter, and if you spread it out over a larger area, it would be darker, with a fixed output in terms of lumens. So measuring that is a little more difficult than just measuring intensity at a point. If I wanted to measure the lumens output, I would really need to build a jig, buy one of those light meters on Amazon. Hopefully they'd be accurate enough for this, and then basically have to measure several points in space using spherical coordinates. So kind of divide it into something similar to latitude and longitude, and take several point samples around it and try to determine from that, you can sum the numbers that you would get up in the certain angles, and you would be able to generate a number telling you the light output in lumens, more or less. So maybe that's something I'll do someday. That's not on my immediate list of projects, unfortunately. I am so busy with fixing stuff here all the time. But that would be something interesting for the future. Give us a better way to evaluate LEDs. So those are some things you have to be careful of. There are other problems with LEDs. Again, LEDs are great technology. They're very bright, they're very efficient, but if you have poor modules, they're just not going to be as good. They're going to be less efficient. They're going to have poor color output. You've seen the green tint on some videos. I think DIY Perks did one on a cheaper versus more expensive 100-watt LED module. For AC powered LEDs in particular, they can emit a lot of electrical noise because they generally have switching power supplies in them, but for whatever reason they're not generally designed very well, so you can have issues like them interfering with your garage door opener. If you put the LED bulb in there and the power supply isn't designed well, it's not very quiet electrically, which a lot of the bulbs I've tried are not, then it's going to interfere with that operation. I actually had to remove the LED and switch back to an incandescent in order to get my garage door opener to work. Otherwise I had to be basically right next to the door or inside for it to work, which kind of made it pointless. So again, just some things to consider. I will hopefully go over more caveats with LEDs and things to be careful about when you're purchasing them in the future. But hopefully you found this informative and entertaining, and I hope to see you again. So please like and subscribe and comment down below if you have any ideas on anything you'd like me to try, and I'll see you next time.